cortex, hippocampus, amygdala. And it is going to be a failure of recognizing something safe. That's what your hippocampus and prefrontal cortex are responsible for. So this is going to sort of harken back to what we learned about our stress response. Hippocampus, prefrontal cortex, they're not engaging when we need them to tell us. In the case of the hippocampus, like we've been here before and we were fine. Prefrontal cortex case, maybe going to be, we know what happens, we know what's going to happen, we will be fine. So like a memory and a future projection, a failure to do that thing. So your amygdala, always going to prioritize reacting, fear. And so it's never going to be the thing that tells you not to be afraid. But something else, the hippocampus, prefrontal cortex, can tell it not to tell us to be afraid. Just shut it down. So if you have heightened amygdala and impaired hippocampus, prefrontal cortex, you a lot of times get expression of anxiety, which is kind of weird because when I was just talking about bipolar disorder, that is an impaired prefrontal cortex, a heightened amygdala. A lot of times people in a manic episode don't necessarily report anxiety. So unfortunately, the answer is that it's confusing. And I don't have an answer for you why in some cases that results in mania and in some cases results in anxiety. That is something that if you want to research, they are researching. But if the amygdala wins, as it does in anxiety, you get your autonomic nervous system response. So again, going back to your stress response, remembering what you learned in this anxiety part is going to be overlapping with when you're studying our stress stuff, because you get your initial alert phase where you have your epinephrine, you have your cortisol response, and you have a fear response. So your emotional, behavioral, and physiological output is going to be more prominent. You're going to react. Whereas if you had functional anxiety appraisal, you would be like, I don't need to react to this. I got this. So prefrontal cortex, this is just slides from our attention and decision-making lectures, kind of, again, the way these things connect together. So like, yeah, those are two separate lectures. Yeah, you'd study them separately. You'd also study them together. You want to know how they connect together. And in this case, I already taught you about the ventromedial prefrontal cortex, and I've been talking about it a lot today on the exam. I'm not going to point to this and say which one is it, but I will say, like, you know, what is the difference between the ventromedial prefrontal cortex and orbitofrontal cortex in function? Or I'll say a true false question, like orbitofrontal cortex is responsible for this, and you'd have to recognize that kind of thing. So overall, they calculate expected value, possible payoffs, social rules. Orbitofrontal cortex is going to be updating your reward value. So in a given moment, how much do you like something? So like in the case of food, if you're not particularly hungry, someone puts a really delicious looking breakfast sandwich in front of you, your reaction is going to be different than when you are starving. And so that's going to be maybe a function of the orbitofrontal cortex, is calculating how rewarding a reward is. The MPSC, which is the one that keeps coming up with mental illness, is going to be assessing risky, ambiguous, and uncertain decision making. So like, if you have impaired decision making, you're still probably not going to put your hand on a burning stove, because that is not ambiguous on whether or not that will backfire. Anything that requires you to really consider the future, that maybe will be ambiguous. Anything that is high risk, high reward, so gambling, like, yes, you can immediately lose when gambling, but you don't know you will. And so that is where the BMPSC is going to be looking at risk. And it's going to be controlling your amygdala and emotional response and your social behavior, recognizing what is socially acceptable. And it monitors confidence in one's decisions. So if with an impaired BMPSC, you may be hyper confident. With an overactive BMPSC, which is what we do see basically with anxiety, is confidence that everything will go wrong. So I know I just said overactive. It's complicated. I'm about to get to the next slide. It's split into two. So damage, you respond based on average expectation and high confidence. So this is OFC, this is VMPFC, high confidence in impulsive and poor decisions. So I just said it's complicated. So these are both parts of the ventromedial prefrontal cortex. So I'm not going to be like, what's wrong with the ventromedial prefrontal cortex in anxiety or bipolar disorder? Because technically, per research, we don't have a hard answer for that anyways. But we do know it's wrong. So this is just kind of, each of these pictures is a different research study looking at anxiety and the prefrontal cortex. So the red is where they found association with negative affect. So negative mood, stress and social exclusion, anticipatory anxiety. Whereas green is positive affect. So objectiveness of social status. So you know, believing you are maybe like stable within your friend group. Pleasantness of reward, fear, extinction, and suppression. So your ability to learn something is safe, even though something bad has happened before, and perception of emotion. So in theory, if this is toned down, you will feel less anxiety. If this is toned up, you will feel less anxiety. And so to say the ventromedial prefrontal cortex is impaired in anxiety just means that this balance is off. Something is wrong somewhere. It's complicated. So trying to think of kind of the big takeaway basically is whatever impairment happens here makes it so that the amygdala is expressing anxiety. So the PFC is failing to stop anxiety. So amygdala, strengthen synapses, support the anxiety response. So the amygdala also split into several parts. Unfortunate. Lateral amygdala is your conditioned fear memory. So bad things have happened in the past. We now know that this is bad because it was terrifying. Your central nucleus of the amygdala is going to be fear expression. So the lateral amygdala has said like, hey, this was really bad and scary in the past. Your central amygdala goes, all right, I will let our body know that. And so it's going to lead to your sympathetic, your epinephrine response, your cortisol response. Basolateral amygdala, in complicated and ambiguous wording, is a valence detector. So it's going to weigh the meaning. How heavily do we feel this thing? And these things are often hyperactive in anxiety disorders. So this is going to overweigh how fearful a situation was. So like, I don't know, last time you approached a group of friends who were talking and everyone got really quiet suddenly. You're like, oh, I hated that. They were probably talking about me. Ideally, you maybe just go about your life. But the lateral amygdala will be like, actually, we can never approach a group of people ever again. That was terrible. That was terrible. And so it's going to hyperreact. The central amygdala is going to kind of hear that, is that memory. And then sort of the valence, basically, this is going to remember that was horrible. This is going to be like, this is the worst experience of my life. So that's going to kind of tell you how much we're reacting to it. And then, yeah, the central amygdala is going to be like, okay, well, you told me this is an anxiety-inducing experience, so okay. Yes, that's what we're going to be doing now. Your heart rate is up suddenly. Prefrontal cortex, so responsible for extinction of anxiety responses. So basically, especially in the case of this lateral amygdala, kind of being like, hey, it's okay. You have approached many groups of people before, and they have let you in. This is one negative experience. It's okay. And so the prefrontal cortex will hopefully mediate that. Cognitive flexibility.